Hi, this is a video tutorial about creating 360 VR video with Unity and a few assets. So I'm in Unity already, as you can see, and I have opened a scene with terrain, some houses, and some dead trees, and a crashed spaceship here in between the houses. What we want to create is a 360 stereoscopic video, let's say a fly-through of that scene. And before we do that, I should mention that in this project I have already imported a few assets. So if we look at the asset store, one of the assets is VR Panorama 360 Pro Renderer. That is an asset that allows us to record 360 videos from within Unity. It's a really well-documented asset, and it has been around for a while, and it works quite reliably. I have also added to the project Lightning Box 2, which is basically a tool similar to the post-processing stack that is free for Unity in its version 1, which is the current version as of end of November 2017. And this Lightning Box 2 comes with a newer version of the post-processing stack that will again be free once it's out of beta. And the distinction between the two is, besides some functionality, that the post-processing stack 2 works in VR. I have also installed the bird flock bundle to enliven our scene. And that is what we find in our assets. So we find the bird flocks, we find Lightning Box 2, and we find VR Panorama. The other assets we find here belong to the scene. So if you have a closer look at the scene, e.g. at the base of the buildings, we see that we could do with some post-processing, add some ambient occlusion here to make the geometry look less flat. And a simple way to do that is by pulling up Lightning Box from the window menu. It's computing a few things in order to make that happen. And Lightning Box is activated, and it immediately changes our scene in a way that is visibly different, but maybe a little bit too aggressive. So we already see that some ambient occlusion is present. We have very hard shadows. We have a depth of field effect in place, meaning the mountains in the background are blurred out. We have a little bit of vignette at the edge. So if we turn the effects off, we basically go back to the original setup. Turn them back on, they are activated again. So we can now fine-tune that a little bit. The first thing we could do is so here we have a few tabs, and in the scene tab we can lower the intensity of the light to 1 and the indirect intensity also to 1. Leave other settings in place. So color space is linear, which is preferable, and the render path is deferred. That is also preferable for good image quality. In the Effects tab, can turn on a few things. So if we look at the sun, we already see some lens flares. If we turn on sun shafts, the sun is getting a lot brighter. And when we look from behind the buildings, we get these nice sun shafts. You can also turn on volumetric lighting. And in the colors menu, we see that color grading is set to ACES, which is fine. We can change the exposure, make our scene brighter or less bright. We can lower the contrast or make it bigger. Change the saturation and the temperature and the exposure and so forth. And in screen, we see that we have motion blur activated. That's not such a great thing when we do VR. So we can turn it off. We can also turn off the chromatic aberration. We turn off the vignette, which can be a desirable effect in 2D video, but we are going 3D video, so I will also turn that off. But not the anti-aliasing and also not the ambient occlusion. If we click that field, we see that the type is set to classic. So look at the base of these buildings here. We, for instance, change that to modern. We get a different set of AO, ambient occlusion. And I think we are also going to see it here at the stairs. Switching back to classic changes this a bit. So does modern. In short, you can change these settings to your liking until you have visuals that fit your need and that you like. So we have screen effects, color effects, just effects, and scene effects. There's something that I cannot change here, which are these very dark shadows. That can be changed by going into the inspector and selecting the directional light. And here we have the shadow strength. And if we lower that, the shadows get a little bit brighter. So we see a little bit more detail in the shadowy areas. I'm just looking where I can change the depth of field. Let me see. So here would be depth of field. We can adjust the range here. So to blur out faraway objects or closer objects, the amount of blur can also be adjusted. So higher amounts would blur the objects further away more, and lower amounts would blur them slightly less. But I think I switch off this effect altogether. Okay, so we have now a clear blue sky here. That is something that we can also change by adding a so-called skybox. There is one in our scene already in the standard assets. It's an overcast skybox. Looks like this. You see on the lower right. And skyboxes are basically textures for the sky, which you can just drag into our scene, and then this skybox gets added. So now we have a much more interesting sky here. And some skyboxes come with the free standard assets. If we go to the asset store and you look for free HDR sky, for instance, you get some more. And if you type skybox, in the search field, and for instance you go free only, you get many more skyboxes which you can use in your projects. Alright, so one more thing, in order to make our scene a little bit more lively, we will add some bird flocks, and for this purpose I will use the bird flocks asset. I think it's a desert, everything is a little bit dead, so I will use vultures. Go to the bird flock vulture folder, prefabs, and we use one of these prefabs. So for instance, vulture flock smooth or free roam. Put this in here, and we get a box. Now I think I will delete this. I will go for vulture flock smooth. Yeah, because that creates a flock when you have this blue box in here. So now this outline of the light blue box shows us the roaming area of the flock. Of course, so close to the ground that doesn't make sense. So we move it up a little bit so that the vultures then fly just above the trees. And I think I will center this flock over the buildings. Zooming out of our scene, I can duplicate the flock with Ctrl D and move it to an area which could be the starting point of our camera flight. This corner, move it up a bit, I think, so it doesn't collide with the terrain. When we have done that, we are going to see vultures flying here. So now we will animate the camera for our video clip, and in order to do that, we create an empty game object, call that, for instance, timeline. We leave that selected, click on timeline. If you don't have timeline, you can pull it up via the window menu. So here you have timeline, and that gives you that function. Unity asks us to begin a new timeline with timeline. We select create, give that timeline a name and also a proper position in our assets folder. So I was in the bird flocks. That's not where we want to have our timeline. Just want it in the assets folders, and we can call this VR clip or something. Save it, and then we get the timeline. So the first thing we do is we actually delete this timeline object here, because we are not animating the empty game object but our camera instead. So in order to do this, we click right on these 3 horizontal lines and select delete. And then we add the object the game object we actually want to animate, and that is our main camera. So we add an animation track. You can add other tracks like audio control or activation. Activation would be that certain objects or game objects appear or disappear at certain points in time, but we want just to animate the camera. So we add an animation track, and then we drag the main camera onto that animator. So now we can animate our camera, and in the timeline here we have obviously a timeline, and here it's in frames. We can change that to seconds, and by spinning our mouse wheel and zooming out, we can look at larger or smaller time frames. We can also set our frame rate. It's currently set to 60, which is not a bad idea for VR videos, because the image transitions will be rather smooth. But obviously, the higher our frame rate is, the longer our rendering time will be. So if we have a scene with only slow movements, we can lower it and speed up our rendering. And in this project, we don't have that many moving elements. And our vultures are also not flying that fast, as you shall see later. So we can use 30 frames. All right, so let's now animate the main camera. In order to do this, we have a record button here in our timeline next to main camera. When we press it, our timeline gets a red bar and it says recording. We have a time slider here, and that allows us to set keyframes in our recording, and we keep it at 0 seconds, and we find a good initial starting position for our camera flight by just navigating the scene. Let's say this would be where we want to start. If we found a good position, we select the main camera and game object, and then align with view. If we do that, the camera is going to be moved to our viewpoint we just took on by moving around in the scene. And it also changes the position of the camera, which is somewhat closer to the buildings now. So a keyframe will be created, as you shall see in the timeline. Keyframe is created by this little symbol here. And in the inspector up here on the right, we also see some values with a pink background. Among them is the rotation. So what we do not have to do is rotate our camera in 3D, because our viewers will rotate their heads in order to look into different directions. So we will reset the rotation of the camera to 0, 0, 0. And we will keep doing this for every keyframe we create. So let's say in 15 seconds we want to have flown to a position much nearer to our houses. For instance, this position here. So we drag our timeline slider to 15 seconds. And again, with the main camera selected, set game object, align with view. So zoom out a little bit from the timeline to 20 seconds, or let's say 25 seconds. And in 25 seconds, we would want to be here in the middle of the buildings. Oh, I'm sorry, I have forgotten to reset the camera rotation. I'll do that now. Okay. And now I'll move the time slider to 25 seconds. So 25, and again with the main camera selected, I align the camera with the view, and again I reset the rotation. So in general, movement in VR should be slow. For the sake of this tutorial, the initial movement will be quite fast, just to render fewer frames. But if you want to have a comfortable VR experience, avoid fast movements and avoid camera rotations, because in VR they will basically confuse your viewers, or some viewers at least, by suggesting a movement that other senses in the body don't feel, and that can create VR nausea. So that last transition from 15 to 25 seconds is quite slow, and that is something you would want. Now let's say at 35 seconds we want to fly up a little bit right above the spaceship. So to have a better view of the buildings and the surroundings. Move the time slider to 35 seconds, somewhere near. And again, game object, align with view, and we reset the camera rotation. So our clip is now 35 seconds long. If we change the indicator of the time to frames, we see it's 1050 frames at 30 frames per second. We can now stop recording, and we can go to our game view, and if we drag our time slider here in the game view, we can quickly see how our animation will work. Could also hit play and have it in real time, like so. So we see that that movement is quite fast, faster than we would normally want in VR. Here it's now slowing down a little bit. And then up. Okay, hit stop. So what if now we don't want to fly towards the buildings right away, but we want to have our users orientate themselves a little bit in the beginning in the original position, so they can look around, and only then they start flying towards the building. And maybe we also want them to remain a little bit at the last position. The way we can do this is by right-clicking into the timeline. So the main camera gets blue color, and we can convert the to a clip track what we just recorded. And if you observe what happens in the timeline, we get a slider, and that slider allows us to move the whole recording along the timeline. So for instance, if we want to have 5 seconds passing before the flying starts, we can do that. And if we want to have our users remain in the final position a little bit longer, we just record more frames. And frames is what we are interested in now as we are approaching the rendering. So we go back to our frames, and we see as we moved the recording, we now have 1200 frames to render, and if we want some more seconds remaining at the end position, then we would render 1350. Sounds a lot, but the rendering is performed on the GPU, so it shouldn't take that long. Let's get back to our assets folder. So just quickly save the scene. And so we currently have a conventional 2D camera, and in order to record in 360 video, we have to add a component. The component is called VR Capture. So in your search bar, you just type VR, and then with the VR Capture asset installed, we get the script, which then has its own interface. So VR Panorama Renderer for Unity. We have to perform a few settings before we can start recording. The capture mode is animation capture, which is exactly what we want. The capture type is equidistant stereo, meaning 2 panoramas are rendered for each frame, one for the left eye, one for the right, giving us then the sensation of depth. We can leave sequence format and JPEG quality as standard. We can also select a custom path, which is recommendable. So we click that. And right now it proposes C VR sequence. So the folder will be called VR sequence. That is fine, but the path C is not what I like. So I will go to some folder on my drive, and so here, for instance, in desktop, I have a 360 video folder. So I copy that path with Ctrl C, and I paste it here, and that gives us then the path where we are going to find our video. I have to add this backslash in order to capture, to put the VR sequence in that folder. I actually rename it to VR sequence 1. Maybe we record some more than. Right. Next thing we select is the resolution. So with VR videos, a high resolution is actually recommended because we are always looking at just a fraction of the rendering. I will select here 4096 by 4096, and we see that the resolution width and height changes. And I will set the frames per second, so FPS, to 30, which is what we were using in our timeline. And if we go back to our timeline, so timeline we want to record from 0 frames, then past our recorded clip, and a little bit longer to 1350 frames. And that is what we put in the VR panorama renderer for the frame rate. So number of frames to render would be 1350. Sounds like a lot, but it should render that in a reasonable time frame. We have now set almost all important settings besides the environment distance here in panorama settings. For outdoor scenes, 2 is too small. So the environment distance determines how the images are stitched, meaning in a panorama we can have artifacts when the stitching is not okay. A higher number, such as 5, it works for an outdoor scene. If you had an indoor scene where objects are much closer to the camera, a smaller environment distance would be preferable. If, say, you have a video clip that starts on the outdoor and then goes to the indoor, it's maybe better to do 2 different recordings, one outdoor, one indoor, with the appropriate environment distances, and join that in a video editing software. Otherwise, the stitching on the interior may not work so well. And one more setting is use depth buffer. We can usually tick that off, especially on laptop graphics card, which don't have that much memory. It saves graphics memory and speeds up the performance. There are some other settings here. So if you use Unity for PC, the asset will automatically encode our video at the end of the rendering. And the rendering is what we are going to start now by clicking Render Panorama. So if you wanted to just play the scene without recording, you would just deactivate the script here temporarily and then activate it again. But I think we are fine, so I will start rendering the panorama. And what's nice about this asset is that we get a preview, and we also get an information regarding the remaining time. As it's 22 minutes, I will now pause the recording and continue when it's done. All right, the video was rendered now, and if we go to the folder where the files from the video rendering are stored, we see that they were both stored as individual image files. You can open one, see things look correct. And in the end, we also get a video file that shows our camera animation. It's a good idea before we proceed to check that, see if there are any glitches or if the stitching is not correct. Here everything looks fine. We see our vouchers flying, and we see the animated camera should stop now. We remain in place a little bit before the video ends. So if everything is fine, we can prepare the video for upload to YouTube VR. And in order to do that, we use the spatial media data injector. It actually comes with the asset. So here we have spatial media metadata injector. You could click on that and it will start. I have already downloaded and installed it. That means I just open it. It's a spatial metadata injector. You can download that from Google. And what this metadata injector does is it adds some data that allows YouTube to understand what kind of VR video it is and how to display it. First step is to open the video. So we go to our video sequence, sequence 1, and select that, open it. And then we have to tell the injector that the video is spherical, which is set correctly. And we also have to tell it that it is stereoscopic 3D with a top-bottom layout, so we check that. We have not recorded audio, so we leave that as is. And all we do now is to inject metadata. We get a file name proposed in the same folder as we have for our image files. So we save that, and then that's done. Go back to our video sequence folder. We get the injected file together with the original video file. The folder also holds our individual images. If you were using a Mac to record that, you may not have the video file compiled already. You can use the individual files in video processing software such as Adobe Premiere to compile that into a video. But in the end, you would inject the metadata, and then once that's done, we can upload our video to YouTube VR. So we go to YouTube and have this upload button up here on the right. Once we click it, we get to this interface. Go to our VR sequence, and we drag the file with the injected metadata onto here. So the file is getting uploaded. That is going to take a while, which is why I paused the video again. So the video has been uploaded. Once that's done, you can, or during the upload, you can give the video a title, some descriptions, and so forth. And you can play the video. Obviously, you would want to play that in your cardboard, but as a preview, you can also play it in the browser. And here you can zoom around with the mouse, see if everything is correct. Looks like here it is the case, and that's basically it. Enjoy.